Video we are going to learn how to work with the joining of the two tables. Okay, so let me quickly start all the Hadoop processes and verify if they're running fine. Okay, so I do have all the processes running. Let us go to a web instance and check if it is launched properly. Okay, so okay, I could see a home folder which is a blank. So we'll do one thing. So like every time, right, we start a new session, I think we are formatting a name node. Okay, the reason for that is like uh, the fs table, right, the table which holds all the metadata, okay, which holds all the entries of the name node. It's stored in a temp directory which is valid only for the active session. Once you are logged out of your node, so the temp directory is getting removed. Okay, in the way it will remove the fs table, and once the fs table is removed, your name node will not know where, like, what data is stored where. So it is always a good habit to format name node in this scenario. So if you do not want to format this name node again and again, and you want to keep all the records of fs table, you can change the directory of fs table to some other directory from your temp directory. Okay, so we'll do that in later sessions, but as of now let us work with the temp directory only. Okay, so for this joining of these two table, I'll use the existing file countries of the world, and along with that I have a new file. So I'll open, I will quickly go through the data set. Okay, so along with the countries of the world, I have this national sports. Okay, so here I have okay, let me open. Okay, it's also fine to open in this library office. So I have this country name and corresponding their national sports. So in the previous data sets we didn't have this sports column, so we will just try to combine these two tables. Okay, so the first step, right, like we'll create two input directories, input 1 and input 2, on HDFS. Okay, so you can also write your HDFS commands in your pig script with this fs. Okay, fs then hyphen rmr, which is used to delete the folders and the directory and the subdirectory. So home directory may contain some folders with this input 1, input 2, the names which we are using here, and it's always better to remove these existing folders. So now once we are done with the creating of these two folders, we'll copy these two files. Okay, one is the countries of the world, okay, to the input 1, and the second is this national sports, okay, to input 2. Once we have these both of the files on HDFS, we'll just load these two files into a pig relation. Okay, so I'll create two relations, A1, which contains these countries of the world. We already have seen how to load data from HDFS colon, and then the local host 8020 and the path of the file using peak storage. So basically these are a structured file, a comma separated file. In B1 also we'll store in the same way. Okay, so now we have two columns, country, which is a type of char array, and then the sport, national sport column, again with the type of char array. So to create a join, this is the syntax we can use: join A1, okay, and the column by which the table has to or the relation has to get joined. So join A1 by column name country, and here you need to specify the type of join. Okay, so as of now, right, I just want only those countries which are available in uh, relation B1 national sports. So I just want the sports, national sports, along with the country, and with that I also want the population and the literacy percent. Okay, so as of now we just create this two relations, C1 and D1. Okay, and let's store this D1, okay, into output directory. We'll create output directory in the home directory only, and we want this file to be a comma separated file. So now we have this MapReduce script2.py ready, and we also have all the processes running. So we'll just quickly execute this file. So let me copy path. Okay, so here is this file, MapReduce script2. We'll also see the other type of joins also. So this is one of the type of join. So you can also give peak-x MapReduce, and then you can just paste the path, hit enter. Okay, we got the success message. So let us verify the files. Okay, now under home directory we have created three directories, two for the input and the third one for the output. So let us verify file. Okay, so as expected, we got the country name, their population, literacy percent, and the national sport. Okay, so here we got, so we have used a right join. So basically this is going to display all the records from the the right side of the table. Okay, the right side of the table is B1, so all entries from B1, and those entries from A1, which has the countries, or the which has the countries which are available in column B also, so the matching records from A1. So we can also use left join. Okay, save the script. So before that we'll just make sure of the count of these records. Okay, so it has only few records, like the in the earlier data set, right, the countries of the world, we had about 227 rows, but here I can see only about 40 to 50 rows. So now if I create a left outer join, essentially we should be able to see all the 227 records. So let me run the script again. So now we have these directories. Okay, so what we will do, right, like instead of creating multiple directories, let us try to remove the existing directories and create the new directories with the same name. Okay, so I'm now running the script. got this success message. Let us verify the results again. This output directory. So this time we got all the records, all the countries from left side of the table. You can see we got all the countries listed. So you can see, like, for some of the countries we do not have any entries. I mean, uh, from the column, from the table 2, because the table 2 only had certain list of countries. Okay, so this country Cuba had records in the files. Okay, other files, like other countries like Iraq, Mali, they do not have the uh, records in the second table, which is national sports table. So in that case, it is going to, give this blank value. So in this similar way, you can, try covering other table joins also. Let's say full join and all. So we also do have one join which is also called as a replicated join. Okay, so if you want to do a replicated join for this kind of a join, right, you need to give this using, and in the single quote you have to give this replicated. So what exactly this is? Okay, uh, like if you are using a multi-node cluster, okay, so the files, right, like these two files, let's say we had the first file which stores all the information, okay, uh, related to population, GDP, and etc. So that file is a huge file. Okay, so that file may be stored on the different nodes based on its size. Okay, and the second file is gonna be a small file. Okay, so while uh, executing this script, okay, for this a replicated join, what essentially it does is it is going to copy the smaller file onto the nodes having the larger files. Okay, in that case, the join query is going to run faster. Okay, and thus the reducing the script running time. Okay, so now we'll see how to work with the unstructured file or the semi-structured files such as XML files. So far we have been, working with the structured file, mostly a comma separated file like CSV files or the normal text files. The unstructured file uh, containing the country's data. So let me quickly go back to the dataset folder. So here countries, and here I have this file XML countries dot text. Okay, I'll just open this file. Okay, now you can see this, the values are available in the tag. Okay, and now if you want to read these files, okay, read the records. uh, so since this is a XML file, right, so every record has a similar pattern. Okay, so the first record is starting from here and it's ending at here. So you can see that the end of the record is it can be verified with this forward slash and this angle bracket. In the same way, this is the second record. Okay, so the data is, unstructured, but it is kind of having a pattern. Okay, so in this case we call this data as a semi-structured data. So now we got this data in the form of only text file, but we are able to recognize that it has a pattern, and it is a XML file. Okay, so there are basically two ways to read this file. Okay, uh, One is with the simple regular expression, okay, which is kind of a very handy. And in the second way, you can use some other loader such as XML loader to load this file and read the data. So we'll go through the first approach with these with these regular expressions. So let us copy this file first to the HDFS. So I have already created a sample script. So first we are going to remove this home directory since it already has some data. We'll create one directory with the name home slash input, and we are going to copy that file to this folder. The name of the file is xmlcountries.txt. Okay, so the path of the file. Okay, and then the this output directory. Now once you have this file, we are going to load the data uh, in some relation. Okay, let us call this relation as a, and then we'll give this load command. And you remember like how to give the path of this file: localhost and 8020. Okay, and the path of HDFS. So you also might remember that previously we have given this condition using and peak storage, and we specified the delimiter. Okay, but since this is a semi structured, okay, the fields are not separated by the comma, so there is no need to use this condition. Okay, so instead we will just have this file as it is loaded. Okay, now once you load this, okay, and we are also not specifying the column names as such here. So to access the values, we have used the indices, okay, starting from 0, $0, $1, and $2. Since we are not giving any delimiter, so everything like all the contents will be stored in a single column. Okay, and you can easily verify that with this $0. Like you can give this, or I can create one more relation to show how exactly this file is getting loaded. So for each a, I'll give this generate $0. Okay, and I'm going to store this relation b onto HDFS in some uh, folder. Store b into, we'll give some output 1, let's say. Okay, there is no need to again give any uh, specifier like how to separate the fields and all. And now once we have all the unstructured or semi-structured data loaded into a, we are going to create one more relation, and we are going to separate the values with the pattern which we have. Okay, so now we have everything in a single column. So for that we are going to use this condition flatten. Okay, so it is kind of it will segregate the entries. Okay, so that we can apply regular expressions To apply regular expressions, you need to give this command reg(x) extract all, and on which column you want to apply this regular expression. So since everything is there in a single column, we have given the index, column index. Now we'll also store this result, okay, on some folder with the name output2. Okay, so now how to use the regular expression and what exactly it is. Okay, so we'll give this regular expression in a single uh, colon. Before that, right, like we'll just copy one sample record. Okay, so we just get the first record copied as it is, and I'll just paste as it is. Okay, now these are the fields, okay, which are kind of getting repeated in every record. So except it will have the different values, and we are basically interested in taking these values only. Okay, so for this, right, like we will use a simple expression dot star, which basically represents like everything. Okay, so the values can be numeric values, can be alphanumeric, or it can contain the special values also, special symbols such as dollar, hash, asterisk, anything. So this dot star represents all. It's the same way like we use it in SQL, right? Select star from particular table. So star represents everything. Okay, so we are again going to repeat this expression with the values. Okay, we are going to replace the values with this expression. Okay, from here. Okay, and I'll store this relation onto this output folder, and I at this time I want these values to be separated by comma. So I'll just save this script. Okay, so map reduce script 3, and we'll execute this script. Okay, looks like we are expecting a semicolon somewhere. Yeah, so we want semicolon at this position, and that's it. So let us save the script and once again execute it. Here is the problem, like now we want for each a, we want to generate. Okay, so since I used the existing script, okay, so there was the some other relation name which I used there. So now the correct relation name is a. So now we are going to again run this. Okay, so this time it is executing it. Okay, we got the success message, and now let us verify the results. Okay, so under home we have this input, which is file which we have used as it is. So now in the first output, right, we have kind of uh, wanted the entries from the first column. Okay, the column essentially contains all the information. So now if you see this part file, you can see like all the records are there in the same form, the semi-structured form. Okay, now we'll go to this output 2 and open this file. Okay, perfect. So at this point of time, we got all the values which are separated by comma. I hope you enjoyed the video. Please do like, comment and subscribe my YouTube channel, and hope to see you in the next video. Thank you.